Hello, good morning, students. Today I'm going to continue your exercise 9.3 sequences and series. Question number 18. Find the sum of n terms of the sequence 8, 88, 888, 8888. Right? You have to find the value of sum Sn. Right? Now, what you have to do, simply take 8 as common. If we are taking 8 common from the given values, the remaining terms were 1, 11, 111, 1000, 111. Now, taking 9 at the denominator and 9 to the numerator means multiply 9 to the numerator and multiply 9 with the denominator. So the values here is 9, 99, 9999, 999. Similarly, 9 can be written as 10 minus 1. This is 10 square minus 1, 10 cube minus 1. Right. Now we simply separate the values, that is 10, 10 square, 10 cube up to n terms, and 1 plus 1 plus 1 up to n terms can be done in the subtraction case, right? Now this is the sum of n terms, so we are using the formula here, that is a 1 minus a to the power n upon 1 minus a, for a is less than 1, but here the value is greater than 1, so we are using a into r to the power n minus 1 upon r minus 1, and the sum of n terms of 1 plus 1 plus 1 is equals to n here. By solving this, we simply get 8 by 9 into 10 by 9, 10 to the power n minus 1 minus n. Right? Simply do the calculation. This is your required answer. Next, question number 9. Find the sum of the product of the corresponding terms of the sequences 2, 4, 8, 16, 32, and 128, 32, 8, 2, and 1 by 2. So what you have to do first, simply multiply the corresponding terms. Right? Means 2 is multiplied with 128, 4 is with 32, 8 is with 8, 16 into 2, 32 into 1 by 2. Now, the further terms were 256, 128, 64, 32, and 16. These terms are in GP because they gives constant ratio of 1 by 2, right? So first term here is 256, the ratio is 128 upon 256, that is 1 by 2, and the first term, and the total number of terms were n is equals to 5. Here r is less than 1, so we are using the sum formula as a 1 minus r to the power n upon 1 minus r. Simply putting the values, we will get S5 as 496. Similarly, question number 20 is there. Find the product of corresponding terms of the sequences. Here also this question is very much similar to question number 19. Here two series were given. Simply do the multiplication here. Right, after doing the multiplication, find the ratio, and this value is equals to small r into capital R. Right, this is the common ratio, which is the required answer. Next, question number 21. Find four numbers forming a geometric series in which the third term is greater than the first term by 9 and the second term is greater by the fourth term by 18. This is the required relation given in the question. Let the four numbers be AR square, AR cube. Here condition is given, AR square is equals to A plus 9 and AR is equals to AR cube plus 18. We are using this relation, taking A as common, and from this second equation taking AR as common. Now using these two equations, divide both the equations. R square minus 1, R square minus 1 were cancelled with each other. We get R as minus 2. Putting the value of R, we will simply get the value of A. So these are the required solutions of the given series, that is 3, minus 6, 12, and minus 24. Next, question number 22 is there. If the pth and qth and rth term of a GP are A, B, and C respectively, prove that A to the power q minus r, B to the power r minus p, and C to the power p minus q is equals to 1. Let A be the first term and R be the common ratio. So AP is equals to A here. That is AR P minus 1 is equals to A. Similarly, for AQ is equals to B, that is capital A into capital R, Q minus 1 is equals to B, and AR is equals to C. For AR is equals to C, capital A into R minus 1 is equals to C. Now taking the LHS part, doing the product of these equations, by simply solving this, we get a to the power 0, b to the power 0, which is equals to 1 into 1, which is equals to the right hand side, right? Next, question number 23. Question number 23 says, if the first and the nth term of a GP are A and B, and if the pth is the product of nth term, then prove that P square is equals to AB square, right? So, in this question, taking R as the common ratio, the first term given here is AN is equals to B, that is the nth term. AN can be written as AR to the power n minus 1 is equals to B. Now, this is the series of the GP. Now, put A is equals to AN, taking R is equals to 1 plus 2 plus 3 up to n minus 1, right? In this, we put the value of sum series, that is n plus 1 by 2. For the sum of the series 1, 2, 3, 4, 5, we are using this formula, right? Now, putting this formula, that is P square is equals to A to the power 2n R to the power n minus 1. Squaring both sides. Now, A into A, R to the power n minus 1 to the power n. We are taking n as common value. Right. Now, P square is equals to AB to the power n. We can write this in the form of AB to the power n. So this is the required solution. Ask if having any doubt in these questions, and do the another questions also. Today exercise 9.3 is completed. Okay, thank you class.